Hello everyone, welcome back. This video is produced as part of assignment 3 of Nature Inspired Programming course at IIT Gandhinagar. This video presents the solution for a multi-objective optimization problem using the recent non-dominated sorting genetic algorithm or NSGA2. We are given the proposed plan for a chemistry workspace of dimensions 25 feet by 25 feet. Two partitions divide the workspace into three divisions: laboratory space, equipment room, and meeting space. The design cost of each division is given in terms of rupees per square feet. Note, laboratory space has the highest design cost. But the partitions have not been fixed yet. We can vary the partitions such that the length of the laboratory space remains between 10 and 18 feet, while width of the meeting space remains between 10 and 15 feet. Now we need to find suitable positions of the partitions so that total designing cost is minimized and area of laboratory space is maximized. Since laboratory space has the highest design cost, the given objectives are in conflict. So the independent variables in the problem are length of laboratory space and the width of meeting space. These variables take values in the closed intervals 10,18 and 10,15 respectively. In standard construction practices, a tolerance of 5 mm is used. Using the same as resolution, the variables will assume 41 and 26 distinct states for length and width respectively. Therefore, they will respectively require 6 and 5 bits to represent all states. Hence, we will have 13 bits in each chromosome for the genetic algorithm. To assign a fitness value to a 13-bit chromosome, we first split the length and width bits, convert binary to decimal, and scale and shift into their respective domains. Next, we calculate the total design cost and the laboratory area. Finally, we put together the values to form a fitness vector. Note the negative sign for the total design cost. Since we will maximize both positional values of the fitness vector, the sign adjustment will ensure we minimize cost. Non-dominated sorting is an algorithm that sorts vectors. We define a vector to dominate another if all its positional elements are greater than the positional elements of the other. In the sorting algorithm, we first assign each vector a rank equivalent to the number of vectors that dominate it. Next, we sort the vectors according to rank. We use crowding distance as a tiebreaker for vectors with similar rank. Crowding distance is a measure of how close the neighboring vectors are along each dimension. In genetic algorithm, we first initialize a random population of 13-bit chromosomes. Then we enter a cycle of crossover, where new chromosomes are produced by interchanging certain bits. Mutation, where randomly some bits within the population are inverted. Finding the fitness vectors and sorting them using non-dominating sorting algorithm. This cycle continues until we get a stable Pareto front, that is, curve made using solutions with rank 1. We ran the NSGA2 algorithm to find the optimal position of the partition. We used a population of 1000 chromosomes, a crossover probability of 0.8 and a mutation probability of 0.1. Here we see the NSGA2 algorithm at work. The yellow dots form the Pareto front, that is, set of all fitness vectors with rank 1. Within 30 iterations, all the chromosomes have arrived to the Pareto front. The Pareto front can be described as two lines with dissimilar slopes joining at the point 180, 252,000. These are the solutions from the domain of the problem whose fitness vectors form the Pareto front. The sharp point on the Pareto front corresponds to the top right corner of the domain. The multiplicity of optimal solutions to this problem means we cannot declare one and only one optimal solution until we can objectively prioritize our goals. But we can say the optimal solution will be a point on the Pareto front if we could objectively prioritize our goals of minimizing cost and increasing laboratory space. Also, for each solution on the Pareto front, we can find a way to objectively prioritize the goals such that that solution becomes the only optimal solution. Thank you, stay safe and have a nice day.